Hi everybody, this is Artin and this is my project for 526 and I'm going to do a Jingle Bells melody, and here is my code. So as I explained in my presentation, after making the input and outputs, that in this case I have clock, reset, some switches, and some LEDs and main output as a melody specified here for the speaker. And then defining some registers and wires, and generating the specific frequency for each note. In this case is E1, that I'm generating the note here. We're saying if the positive edge of the clock reaches, then do the reset. If not, start counting to this number. If this number it reaches, then flip the that specific register, and then that generates the frequency specific for this note. And then we have multiple notes in this melody that we're generating here, like a G1, D1, E1, and so on. And then after that, we divide the entire melody to 97 sections, which is the durations. So, excuse me, each duration has its own specific timing. So for the first note, it needs to continue the note for 2 times of the duration. So that's why we have 2E1 here, and then 1 silent, 2E1 again, 1 silent, and so on. And it goes all the way to different notes like a C1, D1, E1, F, and so on. And then this continues one after each other, and then go from the beginning and continue. And then I connect some LEDs to the corresponding notes, and for instance LED 0 is only turn on when the E1 is playing, and then LED 1 for F1, LED 2 for D1, and so on. So now the question is, okay, this is the code, and then how you connect your input and outputs to the board. How do you know how you connect those? So we have another file over here, which is I named it as a constraint XDC. If we go to this one, this is a file provided by the manufacturer of the board, Digilint in this case, for Zybo Z7. And then in this file, we have some specific options to enable. For instance, in this case, I'm enabling the clock. The clock is, the period is 20 nanoseconds, and divided to 2 sections. Each one is 10 nanosecond, 50% clock. And then the next one is the reset. That is the first switch. And then we have a couple of LEDs that we need to turn on. So which pin is connected? For instance, over here we can see from a specific bank of the pins, like M14, M15, G14, D18. Those are the pins that are connected. And then also for the RGB LEDs, I picked these two. And then the main output that plays the speaker is over here. I named it as a melody and connected to H15. And over here, as we can see over here, the I/O ports, here are those pins. For instance, the LEDs. Here is D18, GM, and different sections of the different banks. And then we can specify the voltage of each pins. We can specify the slew rate of each pins, and the type of the LVDC or regular pin, or there are different options over here that we can pick from. I hope that this okay. Over here it shows that which type of LVDC we can pick from. Differential pair, low voltage differential pair, or other style pins that we can pick from over here. And then to generate the code, we can go from simulation, and then elaborated design, check the schematic, and then do the synthesis, and then run the implementation, and then generate the bit stream, and finally find the target board which is connected, and then program the device. I just did it to save some time, and after connecting, here is the result. So over here, as we can see, I did not have enough LEDs over here to play, so I use RGB. And then the first one is the reset. If I press this, it will reset it and start it over. Happy holidays everyone, and this was my project. Thank you.